statically determinate. That's the first one. Then the second one is the soft support reaction. The third one is using the right direction. Then the fourth one is splitting columns from beam. Then the last one finally is drawing shear force amendment. So we basically have 5 steps. So now we are skipping the first one. The second one is where we are going to now. Step 2. Now to solve step 2, we have to like draw our free body diagram of the frame. So we have what? We have this guy here. 24 times 4 should give us 96. If I'm not mistaken. 96. So you have what? 96 kilonewtons. You have this. And you have this. So this is an inch support. They are RA. Please don't delay very in the question. A, B, and G. So 96 SA. So we have what? RD, HD, and we have what? 12 kilograms here. 2, 8. So we have our free body diagram. So this, now we need to solve our support reaction. So support reaction. Using our 3 equations, summation F5 equals what? 0. This is positive. We have what? Now we are considering all the forces and reactions that are acting in the vertical direction.
On both columns.
On everything. Now, for the second step, we are picking it as 1. So we have RA, 96, and RD. So we have what? RA plus RD equals what? 96. Because it's only 96 that is moving in the opposite direction to it. Do you get that? Now, we are taking, no, the other time, we took it as like, oh, no, not more 1. It's at step 4 that you split. At step 2, you are picking it as 1. So, RD, 96. That's what we have there. Now, summation of FF. So, you have what?
HA minus HD is equal to 2.
HA minus HD
Is equal to 2.
No.
Okay, so.
HA minus equals to 12. HA minus HD equals what? 12. Do you get this?
Yeah.
So, the third one is what? Moment. Taking clockwise as positive. So, want to take moment about A. Let me write MA. Taking moment about A. You know that HA and RA would not have any effect.
Yes.
So we are going to move next to 96. So we have, now let's know that this 96 is similar to like it's acting like this. So moving like this is what? Clockwise. So we have what? 96 times what? 2 plus, what's the next thing that is acting? This is the same thing that is acting here. Do we get? So it's acting like this. The same direction. So it's coming, we are going to A. So it's coming like this.
Anti-clockwise.
Anti-clockwise. So you have what? Negative 12 times what? What's the?
Times 2.
Times 2. Plus, now, RD. RD is coming like this. So minus RD times what? 4. HD would not have any effect.
Yes, it's me.
Because they are both on the same horizontal line. So it's equal to what? 0. So you have 96 times 2 give us 192 minus 24 minus 4RD equals 0. So 4RD equals what? 192 minus 24. 68. Dividing both sides by 4. How is what? 42. So 42 kilonewton. So our R is going to give us what? 96 minus 42. So which is what? 54 kilonewton. Yeah, we have to take moment about
the vertical point.
the inch. But
Yes.
I think we'll take moment about the inch. So let me confirm.
Take moment about B.
Huh?
Take moment about B.
Are you sure?
Yes.
Okay, let's take moment. So let's take moment about the inch here. Taking moment about B. We have what? So we have what? HA will not act.
HM.
It's about B. We still have HA and HD in our list. It will work.
No.
Let me see that. I saw something similar to this. It got to what? 0. So taking a moment about the P now, if you look at it, this HA and HD, they are both on the same horizontal level. You know that time one wanted to do this 12, one wanted to make it easy, we kind of like brought it towards this point. So if you bring HD, you bring it here, it will still be on the same, it will be something like this. Do you get? So we can decide to pick either of it. Huh? Which one? Array. Arrow. No. I'm just like I used to show that 12 the other time. So we can either pick HA or HD. Yeah, you know, like a pin. There's no moment there. That's why we are taking it as moment equals 0. It's not actually moment about B, it's like moment about the pin. But the pin is a what? It's a B. Do you get? Do you get? So now we have so we pick HA. We now have what? We have what? This is going to give us HA instead was to the right. So we are picking negative HA times what? The length, that's what? 4 plus RD. RD is here. Let's assume RD is here. So it's coming like this. So you have what? RD. What do you have for RD? 42 times what? 4. Plus this is here. It's going like this. It's going like this. So down is also clockwise. That's what? 12 times what?
Sorry, is the RD not clockwise?
RD. I got it up here. Sorry. Negative and clockwise. 12 times 2. Please, do you understand it? RA. Okay. So we have that's positive 96. 96 times what? 2. What's 0?
Going to get the same equation that HA minus HD equals to 12.
No, we only getting HA here.
I'm not showing HG.
I said it that we can either use HD or HA. They are both on the same horizontal. I think it's about the P. So now, you see that the other time we were able to like bring 12 to this side. to just make it easier. So if you are bringing HD here, they're still going to be on the same horizontal line. Do you get?
So you just click on it.
You
So
cannot take 2 minutes.
If you take the two, we are still going to be having two unknowns. So one has to go for the other two. For
How do you
them.
know which one to speak?
Eh? You actually tried it too, sure. So you see if you get it. So you have what? 42 times 4 plus 10. So our HA is going to be all of 12 kilonewton. That means HD is going to be what? HD is giving us 0. So let's see whether we are going, if you use HD, let's see whether we are going to actually get it.
If you use it, it's 12. But I'm basically looking for something to cancel out that 12.
That is actually how we are actually supposed to do it, and we actually get this thing. The remaining part of the frame and pick only everything concerning that pin part. So now this one we are going to have what? We don't have any business with this, so we are going to have what? So I'm going to have what? 8A negative 8A times 1 length times 4 is equals to what? 0. So our 8A is going to give us what? 3 here. The 8A is not here, so we can't consider this. And there is not any internal ingest that would say once consider this. You get? It actually makes sense. Why? Because if our 8A is actually 0, it's actually correct. Because on this line, there's no any other force that is. We don't have any other reaction. Do you get? So having it as 0 is already balanced. You know, if our HA is 0, that means our HD is what? Negative 12. And if our HD is negative 12,
It's balancing
it's
without.
balancing that. Now, HA is 0 now. This is, we said, whenever we are dealing with questions like this, we have HA minus HD equals to 12. We have this equation. We are looking for both HA and HD. So now, we've taken moments about it. That's exactly why this internal hinge was there. Because we have to actually take note of it. It's actually active. So now, moment and internal hinge is what? 0. And if the internal hinge is at where? It's at P. That's why they're taking moment about P. And when you're taking moment about internal hinge, you are going to abandon every other part of the question and just focus on what is holding what you want and the internal hinge. So now, we can't use beam. Why? Because the beam, we don't need any, we're not looking for anything on the beam. Like, we're not looking for anything, there's no any unknown on the beam. It's on the column that we have unknown. HD and HA and HD. But there's no internal hinge here. The internal hinge is there, so we are dealing with only this.
So if the hinge was on C, we would neglect this part.
If the hinge was on C, we are going to pick this. Do you get? So that's exactly why our HA is there. And our HA is what? Negative HA times 4. Which is equal to 0. HA is what? 0. That means our HD is going to give us what? H will now give us negative 4. Do we get it now? Sorry, that's kind of like a low formula. So HD is what? Negative 12. So we are done with our support reaction. Now the next step is to use the right direction.
Use the what?
Right direction, that's step 3.
Okay, we'll redraw the frame again.
Yeah, you draw the frame. For me, I didn't take it. Yes, sir.
This last thing, I know it's
I very
last question.
okay. Okay, so I will take it again. It's still the same down right, so I don't want to take it. Now we've gotten RB, we've gotten RA. Abby, we are left with this equation. HA minus HD equals what? 12. So now, we have an internal hinge here. And at internal hinge, like, sorry, our moment is what? 0. So we don't have any moment here. So it makes sense. You know when I wanted to take moments here? That moment here is what? 0. So we need where a moment is what? 0, that there's no any moment there. So we are picking that. And now whenever we are picking internal int, take our moment, we are only considering everything. We are only considering only the components of that internal int. When we are picking moments about internal int, we are only considering the components about the internal int. That means we are considering both this bin and this column. Now, that's the first check. We are considering the components. That's the first check. The second check is now, okay, where is the unknown line? The unknown is lying where? On the column. It's not lying on the bin. So we can't use this. We are using the what? The column. So we are not left with this. Internal int b, then RA will not because they are both on the same vertical level. So RA will not. So we are left with HA. So HA is now going to what? HA times what? Times 4. Do you get? So that's how we have what? Our summation of movement because that's moment about internal int. So we have what? Our HA, negative HA multiplied by 4 equals to 0. So our HA is what? 0. And we have our 0 minus HB equals to 0. HB is equal to negative. No, we can't take limit about arms. Only if there was an internal int there. This small circle is what we're expecting. It's part of the drawing. It came with the question. I mean, the question is on the book now. The internal int came with the question. So that's what we have. So now the next thing is like put everything back on our list. So our HA is 0. It's not going to have any effect. What's our RA? Our RA is 96. Oh, 54, sorry. 54 kilonewton. It's positive. So the direction we chose is what? Is actually correct. Our RD is what? RD is 42. It's positive, which tells us that the direction we chose is what? Correct. Then our HD is what? Negative. Telling us that this direction that we chose is what? Is wrong. So our HD is supposed to come like this. Yep. You can see it's balancing out. Even if you add 40, it is 4 plus 42, you still have 96. So it is balancing it. Now that we are done, now that we are balanced, we are going to step 4. So step 4 is to split our columns and bins and now solve individually. Splitting both columns and bins. So now the first column that we have is this guy here. Now you know the other time in the first question I said whenever we are splitting, we don't know what reactions are happening there. So we're having both upward, horizontal, and movement. Now they made it easier for us to know that this is what? An internal int. So there's no movement there. So the only reactions we can have are the horizontal and vertical reaction. And from your question, you can really see that there will not be any horizontal display. That is 0. Because there's no anything counteracting it. So you already have this is 0 already. Don't see who has shown yourself. So we're left with what? This is
That RBA.
That's RAB. RAB. It's just telling us that we are talking about A and B. So we already calculated your assumption was Fy was 0. You have what? 54 minus RAB was 0. So our RAB is equal to 54 kilonewton. So I don't know that. Don't space here. states. So we're done with the first column.
It's sorry.
And 96. So we have RAP acting here like this. 54 kilonewton. From our column, 54 is acting downwards. Abi? So we need B to be balanced. So another this they have to act upwards at B. So this point here is going to be what? 4. We don't have any horizontal force there. We already know that that's 0. And it's an internal inch. So the moment there is what? 0. So we are left with C. Now at C, we are not going to bring back those our 3 what's the name? The 3 this thing that we know. Upward, sideways, and movement. So this is going to be what? RBC, HBC, and MBC. But from the question, we can see that HBC is going to end up at 0. Abi? HBC is going to end up at 0. Eh? Now, there's a 54 coming down. They are both on B. So to balance it together. So HBC for this part, not for the whole. This HBC is going to give us what? 0. So you can just what? Neglect it. Save your ink and your space. For this step 4, yes, please follow my lead. So do you understand how this is like this now? So now the next thing is to it's fitted it down. Balance it. You get it. So now the basic that. So now you need to solve for this. So for the first one, summation of what? Fy upward equals what? 0. So you have what? 54 minus 96 plus RBC equals what? 0. So RBC is going to give us what? 54 minus 96. That was 42 kilograms. So I done with that. We need to find what? Moment. So we are taking moment about C this time around. So we have what? This is giving us it's complex, it's complex. So you have what? 54 multiplied by what? 4 plus 96 multiplied by minus 96 multiplied by what? 2. Then this is what? Plus what? MBC equals what? 0. What do you have? That's so you have what? 24. About C. Huh? It's not affecting. There's no moment there. So it's not affecting anything. Do you understand how I did this? I'm taking a moment about C this time around. I didn't want to think about B.
Because you are the treatment.
No. You can also think about B. You can think about B after we're done with it. So now this is what? 24 plus what? MBC. So MBC is minus 24 kilonewton meter. Which is telling us that, and this is what I'm saying. Which is telling us, yes? No. MBC is a moment control. So then that's what we're looking for. MBC will stay. So now, we go to negative 24. That is telling us that this sign that we chose for MBC here is wrong. So our MBC initially always was 24 kilonewton meter going in the anti-clockwise direction. It's another because I chose what? Clockwise here. Now, to make it fair and easy, let's take a moment about B and still solve for the same thing. To see whether we get the same answer. Take a moment about B, you have what? 96 times plus we've gotten RBC. RBC is what? 42. Abi? So we now have what? Negative 42 times what? 4. Abi? Plus what? Plus NBC. And that gives us what? 0. So let's see.
Mesmo que você não desse oficina.
We'll still get the same thing. Now we are getting what? 24 plus what? NBC equals what? 0. NBC is what? Negative 24. Now that we still have the same thing. We still worry that it is negative. We still telling us that this sign that we pick is what? Is wrong. So let's go. Take a moment about C. About C. So that means this place will now be what? 24 kilometers. This place is going to give us what? Do you get it now?
Yes, I do.
So we are done with 1, 2. We are left with what? CD. The last one. So now CD is like this. We have what? 40. We have what? 12. And we have what? 12. Then the same way we did the other time, we are picking 3 of it. This. Now, from here, this is what RCD, MCD, and HCD. From here, we already know that HCD is what? 0. How did I know? Because 12 and 12 are already balancing out already. There's no need to come and carry another problem and put it at the end. They're already balancing, they're giving us 0. So we know that our HCD is what? 0. Even our RCD, we can get it easily. Our RCD is 24. Huh? Minus 12. HP. Huh? It's balancing it. Is it this 42 gyro? Sorry. Summation what? Fy equals what? 0. So you have what? 42 minus RCD equals what? 0. So RCD is what? 42 kilometers. 42 kilometers. So you've got an RCD. What's next to our moment? Taking moment about, should we think about C or D? About C. Taking moment about C. You have what? 42 will not act. They are both on the same vertical plane. So you have what? Minus 12 times what? 4. Plus what? Minus 12 times what? No, I'm sorry. Plus 12 times 2. Plus MC equals what? 0. So this is what? Minus 48 plus 24 plus MC equals what? 0. So you have a minus 24 plus MC plus MC is going to give us what? 24, which makes absolute sense because this is both at joint, they are both at joint C. There is already a moment in the anti-clockwise direction. Then this moment being in the clockwise direction is balanced, perfect, it's counteracting it. So the moment here is balanced. So we are done with the moment. The next thing is just shear force and then we mess up. Please do you understand up to this point?
Yes.
Yeah. So shear force for this way, we have FA. Our FA is what? Like I said, we should tilt it. So tilting it this time around, this is what? This is 0, 0, 4, 4. So we don't have any shear force and bending moment diagram in this place. We don't have any shear force and bending moment diagram for this line. We only have an axial diagram. Axial diagram. There are no any vertical forces to this. So the only thing we have here is what? Axial diagram, which is what? Like this, and it is what? Compressive. Compressive of what? 54. Huh? It is compressive because 54, 54 is squeezing it. That's not funny. So for example, F is what? 54. Then before F is before C we have what? FC prime plus 54 minus what? 96 plus minus 42. So our FC is what? Negative 42 plus what? That's shear force calculation. Now the bending moment calculation for this part is what? Yeah? Yeah. That one now. So now the moment here internal in, so the moment at 3 here is what? 0. There's the moment here, so we have to find the moment at 6 first. The moment at 6 is going to give us what? 54 times 4 plus minus 96 times 12. And that should give us minus 24. Yes. Which is giving us what? 24 kilonewton meters. Now, the moment at C itself will now be what? 24 kilonewton. 24. What's the direction of this? Anti-clockwise. So that we have got minus 24, which is what? 0. We are done with that part. The next one is this last one. So make it easier, you can tilt it. So tilting it, you are going to have what? 12, 12, then reaction. Reaction here. Reaction here, clockwise as well. So now let's find the shear force here. The shear force here is what? Wait, not the head. Okay. From here to here, this time out. So the shear force as D is what? Minus 12. Do you get why it is negative? Minus 12. So before C, we have what? Now, just like we did the first question, this is a point load, not a medium. So we can just label this place as what? E. So we are going to find the shear force at E. Now, before E, we have a negative 12 also. At E, we now be minus 12. Yes, minus 12. Plus 12 is 12. Huh? So, now, you are not going to, Fe prime means you are not going to consider E immediately. You are going to consider everything before E. Everything that is happening before E. So that's where we have it. Now, what's the only thing happening before E? Exact negative. So that's where we have negative. So now our FC, there's nothing there. We have what? 0. Do we get it? Now the next thing is what? Your bending moment. Let me separate this thing. So our bending moment for here, we have to have it. For MD is going to be what? 0. There's no moment there. And we can't take moment about D. Huh? Yes. For this one. There's no moment about D. So empty is what? 0. Then empty. Empty is going to be what? Minus 12 times what? 2. Which is what? Minus what? 24 kilonewton meters. That's empty. Now MC, there's a moment at C. So we are going to have what? MC what? MC prime, like we did in the other one. Which is going to be what? Minus 12 times what? Times 4 plus what? 12 times what? 2. That's minus 48 plus 24. Which is what? Negative 24 kilonewton meters. Then MC itself is that what? Negative 24 plus 24. This 24 is a what? Not quite that, so you have what? 0. Bending moment is balanced. So the last thing I will just do. So that's balance. Now the bending moment for this one is what? What are the calculations? MB is what? 0. MC prime is what? 24. Now you can't draw the bending moment yet. Why? Because it's crossed it. Now the exception is. So it's crossed. You have to find the bending moment at this point. At this point where it's crossed, you have to find the bending moment here. So we know that now you can just, it's actually very easy. You can press the calculator. So we have to find the bending moment that is acting at this one, at this point. So now we need to get the distance first. So you have what? This is 0, x, and this is 4. So you have what? X over 54 equals 4 minus x over 42. So you can press your calculator directly. It's not my calculator. First one, this is not your calculator. It's not my calculator. Okay, next. So our x here is what? 2.25. So we need to find the bending moment at 2.25. Bending moment at 2.25. Now this is a video here. What's the total length of the video? 4. But what do we need? We need what? 2.25. That means this is what? Let's assume this, the total length here is what? 2.25. You know you're only splitting it. That means the look here is what? Is active. Abi? Since the look here is active, you have to convert it to what? Point load. So converting it to point load, what is the distance? 24. So you have what? 24 times 2.25. That's what it is. That was 54. Eh? So you have what? 54. So 2.25 divided by 6 is what? 1.125. So this is what you have. Do you get what is happening here? I'm just taking that point of the part of the UDL. I'm just converting it. Do you get it? Now, don't let's forget, there are also some reactions active. You have what? 54. Yeah. Abi? Eh? Reaction at B initially. You know we are moving from B to 2.25. So we need to find the moment about 2.25. So this is now going to give us what? 54 times 2.25 plus 54 times negative 54 times 1.125. And that's going to give us what? That's 61, 60.75. B got 0. At 2.25, which is here, what's the bending moment here? 60.7. This is what? 60.75. Then at C, what's the bending moment at C? 24. This is negative 24. So what? So that was 24, then what? 0. Do we get? And that's basically plotting what we've already saw. So now drawing it now, this is a slope. So you're going to have a what? A what? Curve. So it's coming down. So it's going like this. You're having like something like this. Up to this point. Then this is not a straight line. It will complete the curve. It just up a straight line. So these are our bending moment for this question. For this beam. So the last one is what? The column. Is what? As out. Time is minus now.
Yes, minus. I know 6 now.
You move closer. It is negative 54 times 1.25. 1.125. So that's for the beam. Now the last one, the column, is like this. You have this. What are the several calculations that we have? This is what D and this is what C. At D is what? Negative 12 minus 12. At E, that point that we label ourselves, we also have what? Minus 12. Then at E also we have 0. Then C is what? 0. So you have this. So we have this power. There are no shelves and many uses. So we have this power, our share code. Now, always indicate that it is negative. Because we don't, now, you are doing that column, you don't know which one, which side is negative, which side is positive. So this one is showing that all your calculations here was negative. So now the bending moment is going to what? You have D and you have what? C and E here. So at D is what? 0. At E is what? Negative 24. Then at B also is what? Negative 24, then what? 0. So you're having a slope like this. Coming here. Then a straight line. Then a straight line. So these are our bending moment diagram. And it's negative. So we're done with the question. So I feel like this should actually explain Freeman. I'm not in my assignment question. That's I can't understand it.